demo for your and just you note down the time is 14:41. We are creating the new project. Your college name, Sree Vidyaniketan Engineering College, SVEC. We'll keep the same name, SVEC. SVEC. We have created the project. We have shared this password. We have selected the Andhra Pradesh, Hyderabad, Nagarjuna Sagar, or Vijayawada. Hyderabad seismic zone is 2 and seismic factor is 0.1. Similar way for Nagarjuna Sagar. And whereas for Vijayawada, it is seismic zone is 3 and 0.16. As Tirupati is not in this our drop-down boxes, but we have provided you the map. From this map, you can verify where it is, in which zone it is. And accordingly, you have the choice to select the India, select the other state, other district, other cities, and you have the choice to select the seismic zone as per the seismic zone of India map. That means all the options are available. But whereas for our this demo purpose, we are considering Andhra Pradesh, Vijayawada, seismic zone 3, seismic factor 0.16. Now we'll select the building type, whether it is commercial, hotel, office, residential, or school. We are considering residential. And according to that, unit, meter, up to 13 floors. That means 40 meters height permitted. We are considering 3 floors. Variable height option available. We are selecting ground to first 3.5 meter height. And for rest of the floors, we are considering 3 meter height. 1 to 2, 2 to 3, 3 to terrace. As we have selected the residential building, according to that residential building, as per IS code 875, loads are selected, SIDLL and SILL. For terrace, as per IS 875, it should be 3. And for live load SILL, it should be minimum 1.5. But we are giving you the option, you can select more than this 1.5, but you are not supposed to select less than 1.5. So that we should comply the IS code 875 to make the structure as per the IS compliant. We are selecting the same loads. Similar way, for rest of the floors, we are considering 1.5 SIDL and 1.5 SILL. On beam loads from walls, external, we are considering 9-inch wall, including plaster, floor to floor height, and internal wall, 6-inch, including plaster, floor to floor height, to calculate the self weight, and accordingly, load will be transferred on the beam. And for pyramid, we are considering 9-inch, height 3 feet, that is 0.9 meter. Plinth height above ground level, you have the option. And foundation depth below ground level, that is variable. You have the number of options. But we are selecting 0.75 And soil type, we are considering the hard. That means only bearing capacity of soil, which we require from the geotechnical lab, that we have to enter. We are selecting 300 kilonewtons per meter square. Grade of concrete, M20, and grade of steel, we are considering F145. And rest by default, these values are there. We are designing limit state method based on IS 456 and IS code 1893, foundation as per the working stress method. Now, I will show you 3 options available how to draw on the canvas for this project. Click here to upload the slab data. Slab data, they are nothing but this Excel format sheet. Is it visible? Slab number S1, X coordinate 0. Yeah, Y coordinate 0, X span 3, Y span 3, 6.5. That means 18 slabs are there in the tabular format. We will choose this file from our database. Here uploaded. Close the window. Next. As we have uploaded the slab data, whatever the data we enter, we have got this in this one form. We have selected residential building, unit meters, number of stories 3, below plinth and above ground level 0.6 and 0.75, that comes to 1.35. For ground to 1, 3.5 meter, and rest of the floor 3 meter height. Similar way, SIDL and SIL, for terrace we have selected 3 and 1.5, and for rest of the floors 1.5 and 1.5. 0.23 external wall height, internal wall height 0.15, and parapet 0.23. For earthquake, we selected Andhra Pradesh, Vijayawada, seismic zone 3, seismic factor 0.16. Plinth height 0.6, 0.75, soil type hard, 300 bearing capacity. Concrete grade, main steel. That means whatever data we enter, we got the view. Well, now we'll finish it. If there is any discrepancy, you can edit the project. Otherwise, we can proceed. We'll select the first floor. All the data is converted. That means 18 slabs, which we have made in the tabular format, all they are converted in the graphic format. Another option is we'll select the floor 2. Just to click on anywhere on this canvas, sub-menu will appear, on, off canvas. We will on. Generally, to draw the square, we have to draw 4 lines. But in our case, to save the time, just to click and draw the diagonal. A square or rectangular will be drawn. And the data which we have to enter, you can enter in tabular format instead of Excel format. X coordinate 0, Y coordinate 0. Span in X direction, we will make it 3. And span in Y direction, we will make it 3.65. We'll draw the second slab. Just click, drag, x coordinate 3, y coordinate 0, span in x direction, we will make it 2.3 and in y direction 3.65. Right? Two slabs we have created. We will create the third slab. X coordinate is 5.3, y coordinate is 0. We want to change that. We will make it 1.15. X span, we will make it 3.3. And y span, we will make it 4. It is dragged from this 0 to 1.15. We will create another slab. X coordinate 3, y coordinate 3.65. X span, we will make it 2.3 and y span we will select 1.5. We have created 4 slabs. We will make the mirror image. Select horizontal or vertical. We will select horizontal. Whether it is down or up, we will make up. Y coordinate, from where this mirror image should start. 5.15. Create image. That means this portion, this mirror image is created. Similar way, we will create the mirror image in the YY direction in the right side. We have to mention the from where to start. We will make it 8.6. Sorry. 8.6. Create. Created. We have started at 14.51. Now it is 14.41. Now it is 14.53. That means within 12 minutes, we have created the floor drawing. Two options are available. Either you can transfer the data from the Excel format to the graphic, or you can draw it on the canvas. Now what we will do, we will copy all the slab data to all the floors. We will copy it from the first floor. Floor 3, copy from first floor. Floor 2, even though they are drawn, we will copy again from the first floor. Delete data and continue. Previous data will be deleted and new data will be created. Now we will go to the ground floor. Copy from first. That means we have created slabs on all the floors. As our is the online basis, so periodically we have to refresh it so that the local host and server data should be matched. Slab, first floor, second floor, third floor, and terrace. That means on all the floors, slabs are created. Now we will go to the next menu, that is column. Again on the canvas, back, selecting the location, we'll click We have the option from 0 to up to what floor this data should be, column should be created. For demo purpose, we are doing from top to bottom, all the columns should be there. Rectangular in the XX direction, in a YY direction, second, similar way, rectangular in YY direction. For all the floors, we are creating the columns. Five, 6, 7, 8, 9, 10, on this location where beam is coming from all the direction, we will select the square column for demo purpose, but you have the choice as per the site situation, you can select the square. Rectangular at the corner. Rest we will select the rectangular in YY direction. We have created 18 columns, 19, 20, 21, 22, 23, 24, 25. We have created 26 columns on all the floors. We'll off the canvas. Just we will verify whether columns are created properly or not. They are created on all the floors, 26 columns. Now comes the beam. This is the fantastic which we have incorporated in the software. Auto beam generation. Now time is 14:59. We will create the auto beam generation for all the floors. Okay. By machine learning and automation, all the beams will be created within a 1 minute. $1,500. That means within 1 minute, we have created 43 beams per floor. We will zoom in. 43 beams for all the floors. If we multiply for 5 floors, roughly they came 215. 215 beams created within a 1 minute. And full modeling, we started at 1441, now it is 1501. That means within 20 minutes, we have created the new project. We did the modeling. Now rest, you have to request the analysis. You have to send the email address and phone number, send the request. From our side, we will activate the project. This we kept the check to verify whether the data entered are as per the requirement. Because if the garbage is in, the garbage will come out. To control that, we make these corrections. For your project, we will give you the rights and login access. Many more features are there, but for demo purpose, at this stage, we are ignoring. These are for the project manager, this is for the site engineer, and this is for the site supervisor. We will make the project active and submit. Now, close. We will log in, log off. We will log in SVSC. Forty-three beams are there on ground floor, 26 columns on first floor, second floor, third, terrace. All these slabs are one way by default, right? All the beams simply supported by default. No SIDLN and no SILL. Value 0, 0. These values 0, 0. Now we will do the analysis. We did the slab analysis. No colors. We will refresh it. Proceed. We'll go to the first floor. Slab. All colors 2A, SIDL and SILL are there. That means software will take care of these end conditions, loading, one way or two way, support conditions. Why these colors are different? S1 color is blue, simply supported, other continuous. That means this side it is simply supported and right side it is continuous. S2 left side is continuous, right side is simply supported. Similar way S5, S6, S7. S6 is both continuous. We are kept in the mind. That means if any layman log in and do the analysis, the structure should be safe. Keeping in that, we have tried our level best to simplify the software. Similar way, all these beams will be assigned and conditions and their technical other conditions. For your demo purpose, we already created the similar project. The name is Demo Andhra Pradesh Tirupati and password is your college initials SVEC. We will log in. I mean, you can log in from your system or from your mobile. That means 1441 to 15.5. Everything is taken care by the software within 20-25 minutes. Now this full project is analyzed, design, drawing, bill of quantity, and detailed calculations. All 5-in-1 features are available in this. You have seen this floor menu, then this anywhere you click on the canvas, menu will appear. Plan and elevation. These are the results. Slab results, beam results, column results of that particular floor which you have selected. Floor 1, slab dimension. Floor 1 steel schedule. Means number of bars, 17 number of bars, 8 mm dia at 210 mm. Top steel and bottom steel 25 mm. Number of bars 8 mm dia, 170 mm center to center. That means for all the floors, you have got the result which we require for the execution purpose. Similar way, slab dimensions, thickness, effective depth for execution purpose. Now we are coming to the beam MU, beam bending moment at the center of the column, in the plan and in the elevation. Just we will see at the center of column, the value is 13.86. If we select bending moment at the face of the column, it's a 10.3. That means 3, roughly 25 to 30% less for each and every beam. 25 to 30% saving is there. And we are designing the steel as per this 10.3 bending moment to save the cost. Right? Now I'm coming to the then beam dimensions for each and every floor. Similar way in the elevation, you can see the beam dimension. Same way column dimensions. Zoom in, zoom out, column dimensions. At top, 0.24 by 0.2. As it goes on down, sizes varies. Whereas we have not entered any data. We have assumed it, analyzed it, and finalized it. You will get by this over also. You click on that column, you will get the dimensions. Similar way, on plan also, you can get the dimensions. Beam is still in XX direction. That means XX direction means beam which are in the XX direction so that they can be visible and easy to read. For beam B13, value is for beam 13, 2 number of bars, 10 mm. Similar way, bottom bars 3 number of bars 32 mm plus 1 bar 16 mm in tabular format. Similar way, for the Y side beams, that means beam 32, beam 33, beam 31. On hover also it is available, on graph also it is available. Similar way for column. 4 number of bars 12 mm dia. In this 6 numbers of bar 16 mm dia. And area of steel provided 1206 mm square. Similar way, you can see the elevation also. Zoom in, zoom out. That means all the results are available on one canvas for slab, beam, column. Similar way for footing also. Dimensions, steel details. Now this menu you have come to know what is the feature. Now we'll go to the walls. We have selected the internal walls. The color is different. And for external wall, color is different. To identify, that means which type of wall we have selected. For terrace, no internal walls. Only boundary and color is different as per the pardi. And for floor, 0, no internal wall, no external wall. By default, we have calculated. Now in this, I wanted to show you these separate color, different colors for the beams. That means B12 indicates it's a simply supported at the left and right it is continuous, whereas B13, B14 and B15, they are both continuous, and B16 left side continuous, right side simply supported. And accordingly, their bending moment diagram as per the 3D analysis is taken care. Now we are coming back to the shear force diagram and bending moment diagram. Zoom in, zoom out. Bending moment diagram. For all the sections, section at the 2.15, section at the 4.65. In this case, column is there, C9. And here, no column. So, simply supported. Value is 0. And whereas in the C9, value is different. Similar way, shear force and bending moment diagram. In x-x direction, in y-y direction. Easy to understand by graphical format. Now, we'll come back to the plan. Floor 1, zoom in. Now another dynamic menu. Just you click on the any element, menu will appear. It shows the load. Load means SIDL and SILL. SIDL and SILL. SIDLL is 1.5 and 1.5 for floor 1 and for floor 0, and for terrace floor we have considered SIDL 3 and SILL 1.5. That means very easy to view the values also. Same we know if we click on this beam, load, how the load is transferred from the slab to the beam. As it is two-way trapezoidal, On this beam, from C25 to C16, one beam. So this load is transferred on this particular beam. Similar way for beam 40, load. For your education purpose, you can better understand how the load is transferred. This is the triangular because of the two-way slab. Similar way, the same menu, if we click on the column, check the load on that particular C13 beam, from load is transferred from B13, B14, B34 and B35. On C24, B39 and B26. On C10, B11 and B42. Means it is very clear, visible how load is transferred, gravity load from slab to beam, beam to column, and ultimately to the footing. This is for the gravity load analysis. Now we are coming to the second. This is the calculation, which is useful for your education purpose. Calculation. Navigation bar is at the top for easy access and easy location. Now this is the procedure which we have to follow for each and every element. For slab, dead load and live load, which I have shown you, SIDL and SILL, then floor finish and self-weight, which we'll calculate, and element size, length and width, which we have taken the data from the user. And we are assuming the depth of the section, and we will analyze by two methods, by coefficient method and 2D frame analysis to calculate the shear force and bending moment diagram. Sorry, bending moment. As per the bending moment, we have to design the reinforcement, and after designing, we have to check shear, bending, deflection and development, and at the last, bill of quantity, reinforcement and cement. These are the basic principles to follow. Now we are coming to the slab data. As we have selected slab number S11, that means in the plan S11. This is simply supported continuous, that means these three slabs are in the chain S11, S12, S13. First, as per the coefficient analysis method, we will calculate the shear force and bending moment diagram. Sorry, bending moment. And we have to calculate the required effective depth as per the modification factor and LD ratio. Span is LX 3.3 meters, LY is 4 meters. As per formula, span by modification factor. 3.3, 1.7 modification factor, LD ratio is 32. As per this formula, round off figure is 70 mm. But whereas our IS code says effective depth should not be less than 80 mm. Hence, we are assuming 80 mm. And minimum cover 20 mm. Total depth 100 mm. As per this thickness, we will calculate the self-weight and load, dead load and live load. We have bifurcated dead load and live load separately for earthquake analysis purpose. But for our education purpose, we can jointly say it working load and design ultimate load. Working load is nothing but dead load plus live load, and design load is 1.5 times working load. That you are aware of that. And that calculation is shown in the tabular format. We are calculating the shear, then we are calculating the bending moment. For S11, we did by coefficient method. How, as per the frame analysis, we will verify which one is correct. Slab 2D frame analysis. Now it is two-way slab. As per the end moment conditions, that formula WL square by 12, how the load is transferred, self-weight, and SIDL, SILL. This is the left support, FMA, FMB is the right support. These detailed calculations are there, formula is simple, and as per the formulas, we have calculated and shown in the tabular format. We have calculated the end moments of the S11 slab. Now it's a S12 slab because of the chain. Similar way, S13 slab because of the chain. Now we got the end moments of all these three slabs, and these slabs formulated in the tabular format. Now, as per the distribution factor, again the formula, distribution factor, we have to calculate the three methods, moment distribution, max min, min max, then max max, and the maximum of the three. Simple, which you have learned. But for our earthquake analysis, we required separately dead load and live load. So we did the separate calculation. You can ignore dead load and a live load. Now, ultimate shear load calculations in the tabular format, S11, S12, and S30. These are self-explanatory, and they can be helpful to you for your examination and professional purpose. Similar way, we have calculated the bending moment. 1.5 times, as it is the simply supported at the left, hence it is 0, continuous at the right support, and the value is there. And 1.5 times ultimate, the working moment, we calculate 7.65 kilonewtons meters. And according to that, again, then this is two-way, restrained, all these formulas as per the IS code, table 22.5, page number 36 for your reference, we have calculated. And maximum of the above values we have considered. And the maximum of above values as per the 2D frame analysis, that comes the 7.65, 1.36 at the 1.36. Now, ultimate moment carrying capacity of this particular section, R max BD square. That value is 17.6 kilonewtons per meter. Hence, our section is safe. No need to increase the depth of the section. Now we got this bending moment, and as per the bending moment, we have to calculate the steel. That means analysis is over. Now we are doing the design. Again, we have to follow the formulas as per the IS code. Calculated minimum percentage of steel, bar dia, number of bars, permissible spacing, whichever is less, that we have to select the 240 or 300. We selected 240. Spacing required 180, hence we provided 170. That means each and every step is checked and accordingly selected to satisfy the IS code conditions. Percentage of steel required is 0.36%, and whereas As per the dia and number of bars, it came to the 0.37%. That means very near. Hence, our section is check for deflection is okay. Now, for the y direction is still similar calculation as it is the two-way and corners restraint. We have to provide the top steel, left support, right support. These are the formulas you can understand, and we are providing the results also. Check for the shear and check for the development length. Last is the concrete quantity. Whereas we have taken the data, length and width, and we have assumed and designed the depth. According to that, quantity is calculated. These are calculation for the earthquake purpose. We have shown you for the education purpose to you. Steel weight, number of bars, length of bar, weight of bar. Main steel is 60 kg. Secondary steel is 19.1 kg. And additional top steel, total it is 79.4 kg. Last is the result. Slab is S11, 2A, floor 1, steel grade, concrete grade, effective cover, effective depth, dimensions, quantity. Main steel in X direction at the bottom, at the top, mid span, top, bottom, both. Support, AST provided to the 238 mm square in Y direction and X direction. We are providing you the area also, so that according to that area, you can select the dia and select the number of bars. It's up to your choice. But as per our economics purpose, we are giving the combination which is nearest. Total weight is 79.4. All these are available in this. Your navigation bar, shear, analysis, 2D frame analysis, moment distribution, similar way steel, main steel design, check, shear, check, development length, bill of quantities. For your ease, last is the result. Now we close. This same procedure we adopt for the beam also. We will consider only the single beam P29 calculation. Same navigation bar is there, right? Again the procedure, load from slabs, wall and self-weight. Now we are assuming width and depth of the section. We will do the analysis, 3D analysis, to calculate the shear force and bending moment at the center of column. And we will do the again analysis as per the finite element method to calculate the shear force and bending moment at the face of the column. That is to make the structure economical as well as safe. After getting this bending moment, we will design the section and we will do the checking, shear, bending, deflection and development. Then bill of quantity, reinforcement and cement. We will go to the beam data. As we have selected beam B29, that means only single plane, right? Wall load, again fixed end movements. The load on this slab, load from the slab. That means we are calculating the slab calculation, load from the slab. Summation. Now the 3D frame analysis. As per the 3D, two columns are there, C17 and C21. So as per 3D analysis, that bending moment is shared with them. And accordingly, we have calculated the bending moment at the center of the column. Similar way, dead load, live load, which we require for earthquake analysis. So we had explained to you in three cases: max min, max max, min max, maximum up above. These values are there: 15.31, 15.31. Shear. From here, it starts the finite element analysis to make the structure economical, to calculate the bending moment at the face of the column. It's a very lengthy procedure. It is available. You can view it as per your convenience. Now we will just ignore it or overlook it. So detailed calculations available. Yeah. Now we came to the conclusion. As per the finite element analysis, we got the value 11.98 at the face of the column. And as per the 3D analysis, we got the 15.31. That means again 25 to 30% saving. And according to this face value, we will design the top steel at the left support and the right support, and at the bottom 15.96. 15.96 available, 15.31 at the center, and at the support you can get the 11.98. Similar way, shear force. Analysis is over. Now the design. As we have selected this beam, this is nothing but the L beam. By default, it considered the L beam. That means no need to remember which section, which type, which calculation, which formula. For the L beam, formula is different. For T beam is different. For rectangular beam, it is different. Yeah. We have to check the carrying capacity, 23.94. We have assumed the depth, minimum depth, section depth, and according to that depth, we are calculating. Simple, simple. Same formulas. We have to check the area of steel required, number of bars at bottom layer, top layer, at bottom 3 number of bars, 12 mm dia. AST provided 339. Top compressor steel at mid span, at the left support. At the left support, we have provided 11.98, not 15.31. And ultimate load 1.5 times calculated, and accordingly, the steel is provided at the top, at the left top, and at the right top. Now comes the checking. Beam width check. All these formulas. It should not be less than 200. It should not be conditions, percentage of steel, number of bars, spacing, so that concrete should be placed at the time of execution. Required percentage of steel is 0.5%, but as per our design, it comes to the 0.65%. These table values are for earthquake analysis, 25 load combination. For that purpose, we have formulated and saved here. Shear design, which will be transferred for column and for maximum load. We have to check the shear, ultimate 1.5 times. Shear check, again these formulas. VOC max 145, 57, hence it is set. If it fails, then we will go on increasing the section size. We have not taken any data from the user, neither span nor end conditions, no width, no depth. but we have calculated and we have shown you how we have calculated as per the IS codes. Then stirrups, 2 leg, check for development leg, check for deflection. Yeah. Now this comes the IS code 13920. So that structure should be ductile to prevent the brittle failure. During 2000 earthquake, the structure failed, and after that, IS 1893 came into in the force, and they came to the conclusion that structure should be ductile so that it should give sufficient time to evacuate the humans and safeguard their life. Hence, this IS code 13920, which was from 1993, but it was not followed properly. Now it is mandatory to follow this also. And as per all these classes, we have to comply for each and every element of the column and beam. And we have complied all these and remarks also. Hence, our section is ductile as per the 13920. Then quantity, weight of wall, steel weight, anchor steel weight, stirrups, tabular format result. Beam number B29, floor 1, IS code, grade of steel, grade of concrete, total grade of concrete, size, width, depth, span, 200, 300, 3.65. Whereas we have not taken any data from the user, but we have analyzed, designed, and assigned this section. Quantity, top steel, left support, at right support, 1.5 times, hence it is 17.97. We are providing these values to the user so that as per their choice, they can provide the dia of steel. As per our software, to make it economical, we gave the combination so that it should be near to the required. The number of bars may vary, dia of bars may vary. That means user has the option, they can select, they can provide the dia as per their choice, but it should be capable to carry this bending moment kilonewtons per meter for left support, for right support, and at the center. We have provided the steel area, weight of steel, total steel weight per beam. Now, this is for the load is transferred to the column. And these are the stiffness which we require for the earthquake analysis. Again, we have the navigation bar for easy access. Tools. I will show you this in shear force bending moment diagram also. Shear force bending moment diagram. Sorry, elevation. Why? Beam number is 29, right? Beam is 29. These values are untrue. 15.31 at center, right? That means on graph also, on tabular format also, the same result will be displayed to understand. We have covered 2 points, load calculation. Similar way, we will calculate the column calculation. These formulas, procedures, shear force bending moment, axial, uniaxial, slenderness, everything will be taken care by the software. Column data, load is transferred from B21, B22, B35 as we have selected. Column number C19, B21, B22, B38. Their dead load, live load, their movements, and according to that movement, that section, total load calculated. Yeah. One thing, we are assuming instead of, I just close this, instead of floor 1, I will go for the floor, terrace floor. Calculate the C19. That means at the top, we are assuming section 200 by 200, which is the basic requirement as per the IS code. 200 by 200. And we will evaluate whether it is safe or not as per these loading conditions. We will assume the percentage of steel. We are assuming 0.7% to make the structure stable or economical. Area of column required. Again, the formulas. Then area of column AG, area of required. We have calculated the longitudinal reinforcement as per the 0.7, which is less, but minimum still. It should not be less than 0.8% of the gross cross-sectional area of the concrete of the column. So again, we have revised it, made it 320. Main steel 320 mm. Our section 200 by 200, it is safe. Load is 177, and whereas the carrying capacity is 442 kilonewtons. Hence it is safe. Lateral ties, again IS 13920, loop, hooks, dia, spacing, minimum pitch, minimum requirement, all these 7 conditions, they are satisfied, and accordingly, yes, what I wanted to show you. We assumed section 200 by 200, but as per the spacing, dia and all these, we require minimum 240. Hence, we have revised the section and made the column section 240 by 200. And according to that 240 by 200, we are doing the further calculation. Then PUZ, actually loaded columns, PUX, all these details, first option, second option, three cases, PU-MU interaction chart to compare their stiffness and movement, cylinderness, eccentricity, everything is taken care. We have to satisfy the movement. Section is safe. If it fails, no, again we have to reiterate and increase the sizes. Then PUZ as per the then concrete quantity and steel quantity. Now for floor 1, same column. From top it came 240 by 230. So as per the 240 by 230, we are executing the section, analyzing. And ultimately, it fails. Due to load, the section is not safe. Not safe for action load, revise the section. We goes on increasing the size of the section till it satisfies. Again it failed. Now it is safe. And as it is safe, it is provided. 1 minute. Again, we increase the size. That means it goes on increasing the section till it satisfies all the conditions. Yeah, now it's satisfied. We will go directly to the result. 240 by 388. That means it goes on increasing the section size to satisfy all the conditions. Whereas we have assumed uh, column section 240 by 230, but we have finalized 240 by 380. That is the beauty of the software. I have shown you the detailed calculations of slab, beam, column. Now the drawing. We will see the drawing, steel drawing. Left side simply supported, right side continuous, number of bars, dia bars, everything in the graphic format. Bottom is steel, top is steel, bent up bars, everything is for your similar way for beam. Yeah, I wanted to point this loop, stirrups loop. Previously, we used to provide 90 degree, but after 2000 earthquake, now it is mandatory to provide 135 because this was the main cause of the failure for beams and columns. So it should be noted in future that this stirrup should be 135 bent up. Similar way, column design. Again 135 loop, number of bars, dia. Now last is the tabular format for each and every flow while executing the project at the site. For all these slabs, 18 slabs, floor 1, full results in the tabular format. Similar way for beams. That means same dynamic menu beam B1 up to B43. All these results for that particular floor, B43, tabular format results. Column, 26 columns. Column number, size. We have covered slab, beam, column, load, calculation, steel rank, steel design. Now we will come to the footing. Similar way, same calculation, procedure. This also it's reiteration. We are assuming 330 depth. It failed. It failed. Hence revise the section. We'll go on revising. Again it failed. Again it failed. Failed. Save. Concrete loop ends. It satisfies the condition. Same way, results. Quantity, section size, tabular format. Steel, for upwards sectional elevation. That means we did the analysis, we did the designing, we have shown you the calculations, we have shown you the detailed drawings. Now we are coming to the that means gravity load portion completed. Slab, beam, column, footing. How load is transferred, analyzed, designed, and shown the drawing with step-by-step calculations. If you have any doubt, you can ask, or if you are getting bored, so we can take a break. Otherwise, we may continue. May I continue? Okay. Now we are coming to the earthquake analysis. At floor 1, center of mass and center of rigidity. This is the eccentricity. We should make it that eccentricity should be minimum. At floor 2nd, at 3rd floor, at terrace. Similar way, eccentricity in the graphic format. Similar way, torsion. At 1st floor, 2, 3, terrace. Now it's the coming the drift. This dotted line. During earthquake, building will sway in XX direction, similar way in the YY direction. If you see the values, at the top it is 70, at 3rd floor it is 105, at the 2nd floor it is 143, and at 1st floor it is 110. If we do the static analysis in that way, at top floor maximum value, it goes on decreasing as per the floors. But whereas as per the dynamic analysis, it varies as per the stiffness and other factors that I will show you in that calculation. Story drift in X direction, actual drift of this our project, this value, it's less than 1 mm. And whereas permissible is at 1st floor 14 mm and rest of the floor 12 mm. That means our structure is safe for X direction, similar way for the Y direction. Displacement X direction, displacement Y direction. Lateral force at top it is 70, 105, 143, 110. That means it is variable. Similar way for Y. 70, 90, 134, 134. Torsional shear. Torsional shear Y direction. I have shown you all the results in the graphic format. Now we will see in the calculation in the tabular format. This is the 4th topic, our earthquake analysis. And last is the bill of quantity. On real time, for this full project, we are calculating earthquake analysis by static method and as well as by dynamic analysis method. I am thankful to all of you for having patience and attending the webinar, and that also after lunch hours. Otherwise, that is the sleeping time. It takes 2 to 3 minutes. 1.5 minutes is over. Whatever the results I have shown you in the graphic format, all these calculations will be shown for education purpose. Yeah, we can. These are the steps which we are following. Basic load from slab, beam, column. Then seismic zone and factor. We have selected the city. Response factor and importance factor, as we have selected the residential building. Hence, importance factor is 1 and response factor is 5. Soil spectra, again as per the IS code, we have selected. We have to check the plant size aspect ratio. It should be less than or equal to 3. That I will show you in the calculation. Now, solution is static analysis. We have to calculate the seismic weight, acceleration spectrum. We have to calculate the base shear, lateral force, and shear force. Then center of mass, center of stiffness, and design of eccentricity. I have shown you all these figures in the graphic format. Then comes the dynamic analysis. Multi-degree of freedom, mass matrix, stiffness matrix, Vidyaniketan, natural frequency, natural time period, number of modes, load participation factor. It should be up to 90%. And again, under dynamic analysis, 3 methods. Absolute sum method, square root of sum of squares, and complete quadratic combination. Then all these 4 results in the tabular format, and we have to check with the static shear values. And if these dynamic values are less than the static values, then we have to check up. Again, we have to calculate the torsion, rotational stiffness, shear moment, and ultimately drift and displacement, so that our structure should be non-sway and it should be stable. This is the procedure. Now, as you are the undergraduate students, I feel it's a short for post-graduation, they require in the detail, but it will help you in future career. Just have a look and forget each and everything because you don't require at this stage. As per the clause 7.31, if imposed load is up to 3, then we have to consider 25% value. If it is above 3, then 50%. And according to that, we are calculating the load 25% because our SILL is 1.5, less than 3. Aspect ratio. Our building plan in X direction and Y direction. In X direction, it is 20.8 meters, and in Y direction, it is 10.3 meters. Aspect ratio is 2.02. It's less than 3. Hence, if it is more than that, we have 2 combinations. Either you provide the expansion joint or you redesign the planning. Now, beam loads for all the floors, for column load, all the data, width, depth, quantity, everything is calculated and displayed. Total slab weight, column weight, beam weight. This is the total weight. That means total weight of the building as per the earthquake analysis purpose, it is 10806 kilonewtons. Now basic is this 10806. This is the directly proportional to the lateral force. I will show you. And building height is 14.1 meter as per the height and depth conditions. Already explained you seismic zones. We have selected hard soil and bearing capacity 300. Andhra Pradesh, Vijayawada, seismic zone 3.16. For static analysis, natural time period is minimum should be 2.5. Sorry, maximum should be 2.5 and minimum it varies as per the rock conditions. And whereas for the dynamic analysis, it's a 1. That means as per this graph, we have to follow and calculate. Rock, and according to these rock conditions, we have to calculate this time period. And to design acceleration spectrum, this is the only simple formula. For that, we have to calculate all these details. Importance factor, seismic zone, response factor, SA by G, soil type, which we have covered and evaluated all these values. As our building is movement resisting frame and brick infill walls, natural time period, again this formula, and natural period spectra, it came to these values. Now our total weight is 10806, Z by 2, Z is 0.16 seismic factor, SAG, which we calculated, it came to 2.5 as per this formula, tabular format. And we got the 0.04. That means 4% of this total weight, it will act as a lateral force. If we increase the weight of the building, the percentage is directly proportional. That means lateral load goes on increasing. So we have to make that structure stable during earthquake. Reverse engineering is what? Make this structure so lightweight that lateral force should be directly proportional to that weight. Hence, it should be very low to minimize the lateral force. That is the intention. Hence, from basic principle, we are assuming the minimum section and we are evaluating it, whether it is safe or not. And we revise the section till it satisfies the conditions. Hence, our total project is economical and we are controlling the weight of the structure. For x-axis, we have calculated similar way for y. As our is the symmetrical building, almost same, the values are the same. Now this is the lateral force in the x direction and in the y direction. As per the static analysis, when I told you, at the top floor it will be the maximum and it goes on decreasing as per the floor wise. Before 2000, mostly we used to do design as per the static load method. That means at top maximum load and at bottom less. This is the center of mass calculation. Formula is this only. It's very simple, but the values are different. Number of slabs, 18 slabs are there, number of floors. So we have to calculate the center of mass for all the floors. Ultimately, as our structure is symmetrical, 20 meters in the x direction, 10 meters in the y direction. Almost center of mass and center of at the center. if we bifurcate in the x-axis and y-axis. And where is the center of stiffness? That varies due to the column sizes and beam sizes, which I have shown you in the graphic format. Only this formula we have to apply, and as per this formula, we have calculated the center of rigidity of all the floors. These are the tabular results. And both results, center of mass and center of rigidity, and different colors. Up to here, static analysis is over. Now starts the dynamic analysis. This is the separate software for dynamic analysis, but it is our in-house developed. Hence, we are able to provide free for education purpose. Otherwise, we have to provide the royalty. From scratch, we have designed and developed it. This is the matrix, mass matrix. This is the stiffness matrix. As per the Eisen equation is only this. K mw square absolute value is equal to 0. We have to satisfy this condition. But to show you all the calculation, how the results arrive, we have to follow this full procedure. You can ignore at this stage. Goes on calculating. It's very lengthy procedure. Our ultimate goal is to find out the mode shape. Only these results which we require for further calculation purpose. Mode 1, 5.33. Here is the 5.33. Then 10.74, 10.74. Similar way for mode 2. 5.3 to 8.3, 5.60. This is negative value, negative. To graphic way to understand better. Mode 3, mode 4, mode 5. Right? From here we got the natural time period. Again, we have to satisfy frequency should be 10% mean, well separated. It's okay. Now we have calculated 5 modes. Now what IS code says, total participation factor should be up to 90%. That means 73.42 for first mode, and for second mode it is 72. Summation is more than 140. Hence, for further calculation, we require only mode 1 and mode 2. That means these mode 3, mode 4, mode 5, we don't require for further calculation. But for this purpose, we have to do all this calculation. Now, as per the dynamic analysis method, we have to find out that T, that is separate tabular and separate formula. As per those formulas, we have calculated this time period. And according to these two time periods, we have calculated the shear force and lateral force. One by absolute sum method. Again, the same simple formula, but in the tabular format, we have displayed the values. Then lateral load calculation by model analysis, next direction, SRSS method, and third is CQC method. Again, matrix, very difficult to understand at this stage. We will ignore that. We got the results from 4 methods. One by static method, second by BC method, SRSS method, and CQC method. In static method, it is clearly shown higher value at the top flow, and it goes on decreasing in both direction in X. And for ABS method, values varies. At top it is less, at third floor it is more, and at second floor again more. This is the main reason to do the dynamic analysis. Now in this case, total shear force is 432 as per the static analysis, but as by dynamic analysis, it comes to 93, 69, and 69. What we are doing, we have to match this value. That means percentage, 6%. That means 6 times we are multiplying. That is the Jacob ultimate values. Total is 432. We have matched that values. For each floor, the lateral force we increase by 6.23 times. This is the final value which I have shown in the graphic format 70, 105, and 143 for the XX direction. We did the dynamic calculation for XX direction. Now the eccentricity calculation for the torsion. Only this formula, but we have to calculate for whole the building, whole structure, and frame wise and floor wise. Again, at this stage, we are ignoring it, but for reference purpose, it is available to you. Torsional, which we require ultimately for the drift and stability. Yes. We come to the drift. Again, simple formula, H cube at 12 EI. Stiffness, flow to flow height. As per those formula, we calculated the drift per column, per floor. These are the results. Lateral force as per the dynamic analysis, 70. Floor drift, we calculated. Tabular format. Floor displacement, again the formulas. And the drift ratio. We have calculated the drift and permissible limit also. That means our structure is safe. Then stability indexes. Again, only one formula this. Stability index in tabular format we have calculated and we have to check. What we did, as per the equivalent static method also we did the stability check, whereas for the dynamic analysis also we did the stability check. In both the conditions, even the axial load, where it is 18,463 by static load, and for dynamic load it is 10,000. In both the condition, our structure is non-sway, that means stable. Shear force is there. Stability, it should be less than 0.04. It is less than that. If the structure is sway, then we have two options. Either we have to change orientation, column orientation, or change the dimensions of the beams and columns. So to make it stiff, or we have to follow the 25 load conditions. As we have satisfied these conditions, we are in the non-sway. That means our structure is safe. No need to do the 25 load condition combination. Whatever we did for the XX direction, similar procedure for the YY direction. Mode shape coefficient, mode 1 values, mode 2 values, mode 3 values. You can verify them also. But in graphic format, it is very easy to understand. Right? Directly, we will go to the drift in YY direction, drift and displacement. And in YY direction also, it is non-sway. Our structure is stable. We have covered static analysis, we have covered the earthquake analysis, then design, drawing, and step-by-step calculation. Now last is the bill of quantity. Bill of quantity, steel. Yes, steel bed. Floor wise, grade wise, 250, 415, 500, dia wise. Total steel 4336 for slabs. Similar way for beams, dia wise, total steel 6470. Column, footing, summation is 13,859 kg. While execution purpose, we require for floor wise to place the order. So we have calculated footing, slab, beam, column at the ground. Then first, second, third, fourth. Summation in both the cases, it is 1385, 13859.2 kg, and here it is 13859.3 kg. That means round off only 100 grams. This table you can export in the Excel also for your ordering purpose or placement of execution purpose. Similar way, cement. Floor wise, we have considered M20, grade wise, summation, beam, column, footing, and as per the floor wise for execution purpose. Grand total we require 157 cubic meters, 8 bags, roughly 1292 bags total. We can export in Excel. We have covered all the aspects: slab, beam, column, bill of quantities, earthquake, shear force diagram. Now IS codes. For your reference purpose, IS codes are available. Just you click on the link. You can download or you can view 456, 1893 and 13920. That means everything is under one software for your access, easy access purpose. From my side, I have covered full demo. If you have any query, you can ask me or you can write me or WhatsApp me. It's up to you. Or any suggestion to improve for further civil engineering students' purpose, most welcome. I will appreciate your suggestions. Sir, over to you. Thank you.
Sir, am I audible, sir?
Yeah, very much clear.
Sir, thank you very much, sir, for joining us for today's test lecture. Thank you for sharing valuable information with our students, sir. And it was a wonderful session, and we are delighted to have you here through virtual mode. Next time, we will plan for a physical appearance, sir. We will plan a separate session with you, sir, for our students, so that you can directly come here and share your.
I will be thankful to you. At least by your invitation, I can visit the Tirupati Balaji.
Yeah, sure, sir. That we will arrange whenever you visit.
Yeah.
Sure. I hope our students gained a handful of knowledge from this session, and I request all the students to go through the MvDad.com website, and by using the login details, demo APT and a password SPEC, and practice the artifact analysis, and whatever the star has shared with you, you just go through MvDad.com and make yourself gain knowledge of it. Now I request Miss Navya to give a vote of thanks. Navya, please.
Respected sir and dear attendees, I would like to extend our heartfelt gratitude to our esteemed guest speaker for gracing us with their knowledge and insights in our today's lecture. Your valuable expertise and thoughtful presentation have undoubtedly enriched our understanding of the subject matter. We would also like to thank all the attendees for their active participation and for making this event success. In closing, we express our sincere appreciation to our guest lecturer, Mr. B.P. Karamchandani, for their time and knowledge. We hope to see more such enlightening sessions in the future. Thank you all for being part of this memorable occasion.
Thank you to one and all for attending this webinar. Thank you.
Thank you, sir. Thank you very much.
Thank you, ma'am.